Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss difference between soap and detergent. Soaps are sodium salts of carboxylic acids in long chain, whereas sodium salts of long chain benzene sulfonic acid are detergents. Soaps are biodegradable, while some of the detergents are non-degradable. It can't be degraded. Soaps have relatively weak cleaning action, whereas detergents have a strong cleaning effect. Nowadays, detergents are used for laundering, dishwashing, and many other type of cleanings. Soaps are formed from natural ingredients. Soaps are formed from natural ingredients such as plant oils. Example of plant oils like coconut oil, vegetable oil, palm oil, pine oil, or acids derived from animal fats. Detergent, on the other hand, are synthetic or man-made derivatives. Detergents made from petroleum products and generally contain preservative and antibacterial agents. This is again important point. Detergents made from petroleum products and generally contain preservatives and antibacterial agents. Detergents are potassium or sodium salts of a long alkyl chain with sulfonate group at the end. Sulfonate group is essential. Soaps are known as surfactants because they may assist lowering surface tension between liquids and other substances. And more about the soap and detergent I am telling you. Soap formula. What is the soap chemical formula? It is C17H35COO, and with this either sodium or potassium may be attached. C17H35COO, sodium means Na. If Na is attached with C17H35COO, then it is called washing soap. And if potassium is attached, then it is called bathing soap. And for detergent is an emulsifying agent with the chemical formula C18H29NaO3S. Again I am telling you, its chemical formula is C18H29NaO3S, and the scientific name is sodium dodecyl benzene. Sodium dodecyl benzene sulfonate. This is its scientific name or chemical name sodium dodecyl benzene sulfonate. Now it may be detergent may be of maybe in the form of powder or maybe in the form of liquid. Detergent may be in the form of liquid or in the form of powder, solid. Okay, and it is found in non-toxic form also. Detergents are non-biodegradable, which is really bad for the environment. They cause soil as well as water pollution. Okay, this is not good. Detergents are non-biodegradable, which is really bad for the environment. They cause soil and water pollution. Sodium stearate, two terms I want to discuss which is related to soap and detergent. One term is surfactant. Surfactant. S-U-R-F-A-C-T-A-N-T. Surfactant. What is actually surfactant? Then sodium stearate. In soap, two parts are there. One may be sodium or potassium and other will be stearate. Then sodium and potassium, that is the cation, and stearate is anion. In any salt, two parts are there, cation and anion. Cation is positively charged, anion is negatively charged. Then here sodium stearate, that is a anionic surfactant. This anion, stearate anion, sodium stearate, that is the surfactant, and its chemical formula is CHNaO. Chemical formula of surfactant, that is CHNaO. This surfactant has 17 carbon hydrophobic tail. I will tell about the hydrophobic, and one hydrophilic head. This will be in the dissociated form. Again I am telling you, sodium stearate, that is the anionic surfactant, and this surfactant has 17 carbon hydrophobic tail and one dissociated carboxylate hydrophilic head. There are tail and head. Soap has two parts. One part is head, other part is tail. Then this head is actually water loving. Head molecule is water loving. That's why its name is given hydrophilic. Hydro means water. Philic means liking, water loving. Then head is hydrophilic, means water loving. And tail is water hater. Don't want water. And its name is hydrophobic. Hydro means water, phobic means hater. Hydrophobic. Then these I can say tail and head has actually main role in cleaning the dirty cloth. Actually what happens here, I want to discuss action of soap or detergent, how they are cleaning. Actually to understand these things, one term is there, you have to understand. Micelle. One term is micelle, other term is emulsifying agent. Okay, I will tell both then you can understand action of soap. What is actually this emulsifying agent or emulsifier? Emulsifiers or emulsifying agent, both are same. Emulsifiers can cause two liquids to mix even if they normally would not. They don't want mix. Two liquids, if they don't want mix, but emulsifier can cause two liquids to mix even if they normally would not. Example, that is oil and water. Both will not mix. Oil and water both will not mix. But in the presence of emulsifier, both can mix. Then this I told about the emulsifiers. Now micelles. What is micelles? How it is formed? Micelles. In soap, these two terms are very, very important. To understand the action of soap, these two terms are important. Now I am telling about micelles. Micelles are formed by self-assembly of amphiphilic molecules. What is the amphiphilic molecules? Then what I discussed, head and tail. Head and tail means hydrophobic and hydrophilic. These hydrophobic and hydrophilic, these are called actually amphiphilic molecules. Amphiphilic, both are molecules, head and tail. One is head is hydrophilic and tail is hydrophobic. Then micelles are formed by self-assembly of amphiphilic molecules. The structure contains hydrophilic and hydrophobic. Then hydrophilic means you can tell polar regions. Polar regions, it will be charged. Polar means charged. Then hydrophilic, which is called head, that is the polar region, means it has charge. Polar regions. And hydrophobic, which is called non-polar, it has no charge. Non-polar regions. Then there are two regions, polar regions and non-polar regions. The non-polar regions is tail, hydrophobic, and hydrophilic is head. Actually, now you can understand action. Actually, in soap, these two types of molecules will be there. One will be head, other will be tail. Head is hydrophilic, water loving, and tail is hydrophobic. They don't want water. Then when soap is used to clean the dirty cloth, then soap particles will go near the dirty. Actually, what is the dirty in chemical sense? I am the dirty things, dirty cloth becomes dirty, then what actually happens there? Dust, it will not ordinary dust, okay, that will dissolve in water. But sometimes it will not go simply by dissolving cloth, dissolving in water, it will not go. Dirty will not go simply by washing with water. Then what are that things which is not going simply by dissolving in water, by cleaning with only with water? Then that is actually a strong bond. That will be generally oil and grease. That is called oils and or maybe grease. That is actually main dirts. Easily it will not go. Then this soap will go near that you can say dirty particles. That place it will go, and there actually that cloth is in the water. You have wet it. And now soap you are using, then there near the dirty, this soap will go, and now it will start its action. What will happen? That tail, which is water hater, don't want water, that will start action near the dirty place. That will remove the, or you can tell that will attract only grease or oil. Grease or oil it will attract. That is actually non-polar. That grease and oil is also non-polar, and tail, which is water header, is also non-polar. Then like dissolves like. This is the one this thing, so principle. Like dissolves like means same things. Organic solvent will dissolve organic compound only. Organic will dissolve organic compounds. Inorganic will dissolve inorganic compounds. Inorganic compounds are charged, polar. Then polar will dissolve polar particles, which are charged. They will attract to each other. But non-polar will dissolve non-polar, means organic will dissolve organic. Then here tail has no charge, non-polar. Hence it will dissolve, it will attract only grease and oil. And water header, this is the role of tail, water header. And water loving, other end of the soap, water loving, that is the hydrophilic. What it will do? It will attract water molecules. Then now what will happen? That from that spot, dust place, a dirty place, water will be removed. And this means head is doing in removing the water from that place. From the dust place, dirty place, water is going to be removed by the head, and tail is removing the grease or oil. None. You can say this thing, non-polar is attracting non-polar. Hence both are separated. Water molecules, head will attract water molecules, it will go up, and many particles will be here. This soap, many particles will be there. Means hydrophilic and hydrophobic. Then many particles will be there. Then it will attract, head will attract water molecules, and tail will attract grease or oil. Means non-polar will attract non-polar substances, and polar will attract polar substances. Then now all grease and oil, that will actually come to the core of the soap. They will form a micelle. They will assemble, because many soap particles are there. Then they will assemble. Then all dust particles will come in the center, in the core, near the tail. Head will be up. Then it will look like a circle. All head will be up, and tail will be in the center. Just like soap, you can tell this snake. Snake, you can tell head and tail. Okay, head will be up, tail will be back. Then that many particles are there. All particles have, soap particles will have head and tail. Then head will be up, surrounding like a circle, and tail will be just in the center. Then near the center, all dust will come, and this is called actually formation of micelle, assembly. This is an assembly, that is called micelle. Micelle is formed, and it will be suspended on the you can see it will be suspended on the water. It will be suspended on the water surface. Now that can be, during washing, this both will go. All dust particle will go. It is suspended. It will be suspended in the water surface. On the water surface, these will be suspended. Okay, that can be removed. This is the action of soap. How soap cleans the dirty cloth, I have told you. Then micelles are formed by self-assembly of amphiphilic molecules. The structure contain hydrophilic, means polar region head, and hydrophobic means non-polar region, that is called tail. Micelles are formed in aqueous solution. Micelles are formed in aqueous solution, where you can say this micelles, I told you, micelles are formed in aqueous solution, and this by the polar region, where by the polar region faces the outside surface of the here, micelles are formed in aqueous solution. Already I told you, where by the polar region faces the outside surface of the micelle, and the non-polar regions forms the core. This I have told you, means micelle two parts, that head, or you can tell polar bill, you can say go outside, faces the outside surface of the micelle, and the non-polar regions forms the core. Then this I have discussed the action of soap and mechanism how they clean the cloth. Now I want to tell little more these things. Soap are already told you, soaps are known as surfactants because they may assist lower surface tension between ligands and other substances. Okay, that is surfactant is only the soap only. Okay, and these things, one term is there, soapy and non-soapy. Soapy and non-soapy detergent. What is the soapy and what is the non-soapy? That I want to tell you. Then soapy detergents are derived from natural fats. Soapy detergents are derived from natural fats and acids. Okay, it is derived from natural fats and acids. And soapless detergents, then soapless detergents are made from crude oil or synthetic material. Soap has the ability to dissolve grease and kill germs. This I have told about the differences between soap and detergent. Now I am stopping only here. Thank you.